My dear students, I am going to part of the lesson number 1 of 12th class, that is relation and function. This is also a very important part of this lesson. What is the fourth part? Composition of function. Composition of function. Composition of function or addition of function, you can say that. There are two functions. Let a function f such that a tends to b, and second function f such that b tends to c under f, and this is under g, and second function is g. B to c are two functions. There are two functions. First function f, a to b, second function g from b to c. We want to mix up these two functions, yani composition of these two functions. So the composition of these two functions will be GOF such that A to C. Here F, A to B, G, B to C, and composition of F, G, GOF function such that A to C. This is the composition of these two functions. And by taking an example, the composition of and G is denoted by GOF, and composition of this is a composition of F and G. And if you want to know the composition of G and F, that will be FOG. Composition of F and G is GOF, and composition of GOF is equal to FOG. So by composition, I want to make it clear with the help of example. A, this is B set, this is C set. From A to B, X under F have images Fx. B to C under G, image have Gfx. Here you see X, image Fx. Here Fx is element of B. Then under G function, image of Fx is Gfx. And composition. This is the composition. This is GOF. GOF means the element X in A has image in C, Gfx. Understand? Element X of A has image under GOF, Gfx in C. X is element of A, Fx is element of B, and Gfx is element of C. But here X, Fx is a image of X, pre-image of X, and Gfx is a pre-image of Fx, or Fx have image Gfx. So this is GOF function. So in this way, two functions, f from A to B, second function g from B to C. When we combine both these functions, you will get GOF from A to C, direct from leave B, and from direct from A to C. This is the GOF function. Now, one thing, note, GOFX is equal to gfx. Note it, because when we take example, you will be you have to write this, and f4gx is equal to fgx. These are the short form. We have to apply in the examples. Now, example 1. One thing I want to tell you, that this function is 1 1 and this function may be 1 2. This function is 1 1 and this function is may also be 1 1 2. Here, this composition of these function. Also, we have to prove that whether it is 1 1 or on 2 with the help of example. So in part third, we have proved that this f is 1 1 or on 2, g is 1 1 but not on 2. So 3 or 4 questions we have taken, and you have seen that the which function is 1 1 and which function is on 2. Here in this composition, in the GOF and FOG, we will also prove that this function is 1 1 or on 2 or both. I am going to take an example. So that, example first, so that if a function f such that a to b and z and g such that b to c are 1 1 are 1 1 are 1 1, then GOF is also 1 1. Very good question. Here, f is a function from a to b. This function is 1 1. G is another function from b to c. This is also 1 1. And the composition of these two functions is GOF. This is composition. Composition of these two functions is GOF. And we have to prove that this composition is also 1 1. Very important. We have to prove that GOF is also 1 1. Now let GOF x1 is equal to GOF x2, where x and x1 and x2, two elements of GOF function, two elements of under GOF, two elements of first set under GOF. So GFX1 is equal to GFX2. I have told you that this can be removed, O can be removed. Now here, first, G is 1 1. G is 1 1 given. Hence, Fx1 is equal to Fx2. Remove this C, because condition for second. F is 1 1 given. So remove this x1. X1 is equal to x2. Hence, x1 is equal to x2. Hence, our assumption, we have assumed that this function is 1 1. G of x1 is equal to g of x2. Here, we have let this function, this is g, this is 1 1. And here it is proved that this is 1 1. Our assumption was right. Our assumption was right. Hence, G O F is 1 1 function. 1 1 function. Proved. This is the example. Now I am taking second example. Now I am going to take second example. Second example, so that function, so that if f such that a to b and z b to c, g such that b to c are on to, then on to prove that GOF is also on to. This is the question. This is the second question. Second example. Now, according to the on to condition, I have told you in the third part, on to, what was the on to condition? What is the on to condition? If a element belongs to B set, that element should have a pre-image in A set. Here, an element first, an element, an arbitrary element, Z belongs to C. There is a one element belongs to C because we have to prove this function GF from A to C. This element belongs to C. It means this Z certainly has a pre-image in B. This is the on-to condition. G, under GF, under G, such that GY is equal to Z. This was the condition. Z belongs to C, under B, under G. This Z belongs to C. Z certainly have a pre-image in B, and that pre-image is Y. So function is G. So GY is equal to Z. This Z has pre-image Y in B. Again, there is a second. Now, this Y is a element. Now, this Y is an element of B, and it must have pre-image in A under F, such that F Y is an element of B, it must have pre-image in pre-image X in A in A under F such that Fx is equal to Y. This is the condition. When there is if Y belongs to B, it means this element under O2, this element must have pre-image in A. Then the condition will be satisfied. So Fx is equal to Y. Now therefore GOF X GOFX is equal to GFX is equal to GFX. Where is Fx? This Y. From first GY and from second GY is equal to Z. Here this is second. GY is equal to 2. GY is equal to Z. This is Z. GY is equal to Z. This shows that here you see that Z belongs to C and this X belongs to A and this X belongs to A under GOF and Z belongs to C. This is the condition of onto. This shows that this shows that this shows that GOF is onto. This shows that GOF is onto because Z belongs to C and X belongs to A under GOF. For onto condition, GOFX is equal to Z. This is the condition. This is the condition of onto. My dear student, with the help of these examples, I think all the concept of 1, 1 and onto has clear and you have understood very well. I think so. So this is the fourth part. This is the fourth part of the relation and function of 12th class mathematics, and there are two parts more of this chapter, 5th and 6th, and these two parts I will take later on. And one thing I want to make a request to you, please subscribe this channel also. Thank you.